Hi, let me get started. I'm William Munn from Georgia Tech, fourth year PhD student working with Dr. Krishna. And this is hands-on exercises about using ASTRA-sim. We have 4 exercises. I will run the very first 3 and then hand over to Taekyung. Because all the topics about distributed training and ASTRA-sim's detail was already covered in the previous topics. I will go over more on like writing the actual inputs and how to use it and various hands-on stuff. So this is the first exercise. So I will let you guide how to install ASTRA-sim, how to download it and compile it, and then running some simple input files, and then run it, and we'll let you know how to read the results. So to download the ASTRA-sim, here we have the URL to the installation website. So when I go there, so this is our ASTRA-sim website, and here you can see we have this MLSys tutorial page. And then when you go there, on the bottom, you have this installation button. And if you click there, I have just listed all the dependencies we need. So you may just go and install it. Then I also put how to install ASTRA-sim and whatnot. But for the sake of this tutorial, what you should do is we have this Git repository, so you should clone it and then go to the MLSys folder and run this clone ASTRA-sim script. It will automatically clone ASTRA-sim and change to the designated branch. So I'll do the very same thing here. So I will clone the ASTRA-sim tutorials repository, go to the tutorials MLSys 2022 and run the clone ASTRA-sim script. And it is running, it was cloning and downloading all the related repositories and sub-modules. Meanwhile, downloading it, if downloading those prerequisites and dependencies are tedious, we also offer you this Docker image that already comes with ASTRA-sim, downloaded ASTRA-sim and installed dependencies. So if that's more suitable for you, you can just pull this ASTRA-sim MLSys 2022 tutorial Docker image and run it. So seems like my ASTRA-sim has been downloaded. So once it has been fully downloaded, what you can do is go to the exercise 1 folder, and there we have already created this build script, which is nothing but compiling ASTRA-sim using CMake. So by running this, you can download and compile ASTRA-sim. So I will do this thing. I will go exercise 1 folder and run the build script. And as you can see, it's building the ASTRA-sim. And I'll just wait about 1 or 2 minutes to finish it. Yes. By the way, this is ASTRA-sim with analytical backend and text-based input for the sake of simplicity. But if you want to run like more complex network backends like Garnet, we have GitHub repository that has detailed README how to install those network backends as well. So you may just refer to it if you're interested. I'm just waiting a bit. So on my side, the build has been finished. So let me resume. So till now, I just guided you how to download ASTRA-sim using some simple script and how to compile it with the proper dependencies. Yeah, it may just compile properly, and if not, just like please use Docker because it comes with all the required stuff. Then the simple exercise I want to run is create some ring topology with 8 GPUs and then run 1 megabyte all reduce on it. So yeah, this is the detailed view of the topology I want to test, which is simple ring with 8 MPUs. And each link here, like I want to use is 5 nanoseconds link latency and 50 gigabytes per second link bandwidth. And what analytical backend also requires is how many links are being utilized per each MPU. And as you can see, each MPU is using 2 outgoing links. So by using these numbers, we can create some text-based JSON file just representing this topology. So going those inputs line by line, this ring is simple 1D topology. And of course, this ring topology is being used. And we have 8 MPUs in total. And per each MPU, the number of links is, as I said, 2. And the link latency and link bandwidth is 500 nanoseconds and 50 gigabytes per second. And every time you create this network info file, you should also create the system info file that's directing how to run collectives in ASTRA-sim. So in the system info file, you designate all those ASTRA-sim system related inputs, like what is your FIFO scheduling policy, how long each endpoint should wait, and like how many active chunks per each dimension. But yeah, you can go to the ASTRA-sim repo, and there you can see all the detailed descriptions about all those configurations. But the core for this tutorial is just this tool. So when running 1 megabyte collective, this preferred data set split is 4. So we will split that 1 megabyte message into 4 chunks. And the all reduce algorithm we want to run is ring algorithm, because we are running this on ring topology. So ring all reduce algorithm is the topology of a collective that's not creating any congestion. Then those network and topology and system info file has been created. You should finally write this workload file. So workload file consists of 3 parts: the training loop, number of layers, and the layer data line by line. But we are not running actual workload for now. We are just running simple micro benchmarking of one collective communication. So that's why the training loop is micro, and we only have 1 layers. And that layer can be break down into multiple information like shown in the table. But the core is for each forward input gradient and wait gradient passes, you should designate the compute time, communication type, and the communication size. But here we are not testing any computation, so the compute time, I just set it to 1. And the communication, I just randomly put it in the input grad dimensions. And as you can see, the communication type is all reduced. And the communication size, you should put it in bytes. So I just put 1 megabyte in this bytes number. Then all those input files has been created. We should now call ASTRA-sim with the created inputs configuration files. So this is a simple script, exercise 1, that's being offered, which is nothing but running ASTRA-sim with the run name exercise 1. And I'm just designating the created network system and workload input files. So just to go over to the tutorial file tree, I'm currently at this exercise 1, and inputs, as you can see, we have like all reduced workload info file, ring JSON topology file, ring.txt system info file. And here the exercise 1 script is nothing but running 1 instance of ASTRA-sim. So I'll just run exercise 1.shell script. And as you can see, it finished very fast. And the core data to look at is this number. All passes finished at time about 46,000. So now we've run ASTRA-sim on 1 megabyte all reduce on an ASTRA ring. And this is the reported number. What we can get from here is that the collective time was about 45,000 nanoseconds. In other words, just 45.6 microseconds. So this collective communication on an 8-size ring that's using 50 gigabytes per second link bandwidth almost took about 45.6 microseconds. And this also dumps the log file, not just the standard output, and that's stored within this results and tutorial results.csv. And it reports the total time taken, the compute time, and the exposed communication time, and the total message size sent out per each MPU. Here, the total time, as mentioned, is about 45.6 microseconds. We had no compute. That's why all communication time has just been 100% exposed. And to run 1 megabyte all reduce, the total message size sent out per each MPU is reported to be 1.75 megabytes.